Okay, so it's brought to my attention that maybe you guys haven't done a huge amount on functions. So the thing is, before the mocks, I probably won't get a huge amount of time to revise functions. We could use one of the revision classes beforehand, but if you haven't done any functions at all, it's really important. Or if you just don't remember any functions, it's really important that we go through some of the basics before we even do the revision. So I've just lifted from the book a couple of screen grabs, um, just to go through some of the parts. So this is actually the functions chapter in the higher level book that we're using is actually all just about graphing functions. So we have to look back at the first active maths book to talk about the introduction to functions. So if you have a look over here, I'm just going to highlight this section here. And that's the definition of a function. So a function is a rule that maps an input to a unique output. And that's a really fancy way of saying when you put one number into a function, it will give you out a different number. Or, sorry, not or, and if you put, say like you put the number 1 into a function, it might give you the number 2. And if you put 2 into the function, it might give you the number 3. That's all it's talking about. That whatever you put into the function, it will give you out something. That's all. It's a concept. It's an idea. So that's what they say here. So in this section that they've kind of showed it using a machine. So 3, hang on, I'll get rid of that actually. Where's my undo button? There it is. So we're looking at this. I'll highlight this in green. All right. And then I'll use blue to show. So if 3 is my input, that's what they're saying there. And the rule is to double the input. Then 6 is what comes out. Because when I put 3 in, I double it. It becomes 6. My output is 6. That's a function. So you put something in, you get something out. That's the idea of functions, the way to think about them. Two ways of thinking about it is that, they have the example of the remote control down here. So a remote control, if you press the number 1, it might give you RTE1. If you press the number 2, you get RTE2, Another thing about functions is one input cannot give you 2 answers. That's not possible. But 2 inputs can give you the same answer. So look at this example here. I'll highlight it in purple. All right. So no, hang on. That's too big. Let's make this a little smaller. So if we look at this example here, all right, the -2 goes in and the rule is to square your input, right? So if I square -2, I get back +4. But look at it. If I apply the same rule again, I put 2 into the input, I square 2, and I also get 4. So we have one input there, a different input here, but it gives us the same output there. All right. So that's something. A function can result 2 different inputs can give you the same answer, but one input will never give you 2 answers. It's not possible. Okay. Typically speaking, functions are named with the letter F. All right. They come in a few different ways. So you can have f of x. You can have f dot dot x and an arrow like that. That's x being mapped on. But they're all the same thing. You see f and an x together, you're talking about a function. All right. So on the next page, they talk about mapping diagrams. So this is just a visual way of showing some of the functions that we deal with, right? So a mapping diagram, our list of inputs, the things that we're going to put into our input is going to be given its own oval shape here. So I can draw it out over here. So if I do a little oval shape like that, so this represents my inputs, and these are going to get mapped onto my outputs. All right. So the rule in this case is multiply by 3 and add 1. So my inputs that they've chosen are 4, 1, and 0. So I start with 4, I multiply him by 3, that gives me 12, and I add 1, gives me 13. And that's why you have 13 there. All right, let's try the same with 1. So multiply 1 by 3, I get 3, add 1, it gives me 4. And for this guy, 0, multiply him by 3, I get 0, add 1, I get 1. All right, it's just a visual way of representing the inputs and outputs. All right, so if you look over here, they have remember I was saying, so one input cannot result in 2 outputs. That is not possible. Hence why it says f is not a function. All right, over here, you can get 2 inputs resulting in the same output. So that is a function. All right, and over here, if one of your inputs does not have anything, does not result in any output, then it's also not a function. Okay, so they're just a couple of the basic rules. All right. Now, if we use the example that I have here, all right, that they had, and I've done it out here again on the right, 4 resulted in 13. So I call him a couple. So you can write him almost like a coordinate, 4, 13. All right. The next couple would be 1, 4, and the next couple would be 0, 1. All right. So that's a couple. And you can write them as a set. So you do your curly brackets and you just stick them in. So 4, 13, 1, 4, and 0, 1. All right. So that's couples. All right. You can also do an input-output table. This is a little bit more technical, but I actually think it's easier. But, you know, you guys might tell me otherwise. But if I draw a table here, okay, so, okay, I'll just draw a line like that. And a line like that. And a line like that. It's not my best table, but it'll do for the moment, right? So you can put your inputs here, the rule here, and the output here, right? So just try this out. So the inputs we picked were 4, 1, and 0. The rule was triple or multiply the input by 3. So 3 times 4, multiply the input by 3 and add 1. Multiply the input by 3 and add 1. Multiply the input by 3 and add 1, which gives me 13, 4, and 1. And I'll just highlight my couples in pink. So 4 and 13 is a couple, 1 and 4 is a couple, 0 and 1 is a couple. Okay, so that's the theory behind functions. Let's have a look at some of the examples that they have here. So each of the following mapping diagrams represents a relation. Identify the mapping diagram that also represents a function. So if you have a look at the first one here, right? So A, each individual point or each individual input is mapped onto a single output. That's legit, right? So that's why that's that's a function. That's allowed, all right? But have a look at this one here. One guy results in him, he's fine, but this guy is giving me 2 outputs, which we said is not allowed. So that guy is definitely not an input, okay? Or sorry, not a function. Part C, I have 2 guys and they are giving me 1 output. And there's another guy sitting here, but he's okay. You're allowed to have a spare guy in the outputs, all right? Because it's still a function. But over here we have a problem because this guy does not map onto anything here. So he is not a function. All right, so that's just what they're showing you there. In worked example 31.2, it says, from the following ordered pairs, draw a mapping diagram to illustrate the relation T. All right, so they've given us a bunch of couples. All right, so to show those couples, I draw my domain and range. So your inputs, the list of your inputs is referred to as your domain, and your list of outputs is referred to as your range. All right, so I'll highlight the domain values in green. So that's -5, 1, 2, 6, and 5. All right. And then in pink will be my range values, 15, 1, 4, 36, and 25. All right. So let's start with our domain values. So -5, 1, 2, 6, and 5. 2, 6, and 5. Now, I know you might spot there in the book that they've done it kind of different, okay? The reason for that is because, I'm actually going to copy them because it'll get a little bit messy if I don't keep the 5s together there. And 1, 2, and 6. And my range values are 25, 1, 4, and 36, all right? So 5 maps onto 25, but so does -5, all right? 1 maps onto 1. 2 maps onto 4, and 6 maps onto 36. So there I go. I've answered it using a mapping diagram. Is the relation T a function? It is a function because each individual, so look at 1, 2, and 6, they're individual inputs that result in individual outputs, while -5 and 5, while they're different inputs, result in the one output, and that's allowed. So T is a function, okay? Then the last worked example, 31.3, a function machine has a rule that states double the input and subtract 5. All right. So it says write the inputs and outputs of this function as a set of ordered pairs. So I'm going to do what they did, and I'm going to use the two-way table. So There's 4 inputs. I'm going to make a relatively big table here. Oh, hang on. If I just do one big box like that. Okay, and then we want 4 lines. 1, 2, 3, 4. All right, sorry about that last one, guys, but we're kind of don't want this video to run on too long. So our inputs go here. Our rule, well, the way they've done it actually is kind of cool. So you say rule, and then you describe what it says. So double the input, and subtract 5. All right, and output is these guys here. So let's do that. Our inputs are 1, 5, 12, and minus 5, right? So that was given to me, all right? That's given to me there, 1, 5, 12, and minus 5. And the rule says double the input. So the input is 1, so 2 times the input and take away 5. Over here, 2 times the input, take away 5. 2 times the input, take away 5. 2 times the input, take away 5. Now, if you want, I have a little bit of space here, so I'll actually do the sum. So 2 times 1 is 2, take away 5 is minus 3. My output is minus 3. 2 times 5 is 10, take away 5 is 5. So my output there is 5. 2 times 12 is 24, take away 5. Sorry, that's the dog just wants to get out here. So 2 times 12 is 24, take away 5 is equal to 19. So that's my next output. And finally, 2 times minus 5 is minus 10, take away 5 is going to be minus 15. All right. And it says to write it as a function of ordered pair. So that just means I use my set notation. My first couple is 1 and 3, or minus 3. So 1, minus 3. My next couple is 5 and 5. So that's 5 and 5 there. 12 and 19 is my next one there. 12 and 19. And finally, we have minus 5 and minus 15. All right. Oh, sorry. Well, look, I'm not going to change the color now, but there you have it. And you just close off there. Okay, so I'm going to leave the video there for now, guys. Keep an eye out. I'll throw up a video or two of worked examples, but for the moment, that's just the theory. And have a crack at the questions yourself. All right, if you can, well, that's if you can dig out your Active Maths 1. If you can't, just hang on. I'll have a video up soon of some solutions. Okay. Lads, not to sound like a subscriber or anything, but if you could actually just let me know if these videos are useful. I'm just going off views, but like if you find it useful, please let me know in class, because these do take a little while to do. All right, so it would really help if you just let me know if you're finding them helpful. Okay, right, see you in class.